looking at these and we're asked to find the exact values in the inverses are defined. This is going to be slightly different than our next section, in which I want all real numbers that satisfy it. Right now I want to know where the inverses are defined do I get the answer of 1/2. So you have to think about where the inverse is defined for sine. Where is sine defined for the inverse? Which quadrants? Quadrant 1 and quadrant 4 in reverse. So which angle produces 1/2 in those two quadrants? Pi over 6. So your answer for this first one is just pi over 6. It is not in quadrant 2 because sine inverse is not defined in quadrant 2. So go ahead and finish these off. Think about where you are defined in terms of the inverse.
What's defined again?
Sorry, what?
What is defined again?
So defined means is where do I get to choose values for my inverse? Which quadrants do I actually have the inverse in? So sine is in all quadrants, but the inverse is not, because it has to be 1-to-1. So we defined the inverse in two quadrants. And it says, where is the interval defined? Well, tangent inverse is defined between negative pi halves and pi halves. To get a negative 1 in that quadrant, that this x here must be negative pi over 4, because I only get to choose quadrants 1 and 4 in reverse. What gives me that answer in those two quadrants? Cotangent, where's cotangent inverse defined? Which quadrants?
0 and pi.
Between 0 and pi, so quadrants 1 and 2. So in quadrants 1 and 2, what gives me the cotangent of negative 1?
3 pi over 4.
So it is x is equal to 3 pi over 4 for that quadrant. Secant, where is secant inverse defined? It is the buddy of cosine. Where is that defined? Which quadrants? 1 and 2. So between 0 and pi. Which one gives me the square root of 2 in those two quadrants? A positive answer in those two quadrants. Pi over 4. Last one is cosecant. Cosecant is the reciprocal of sine. Which quadrants is the inverse defined in? 4 and 1. 4 in reverse and 1. So where is the cosecant going to be negative in those two quadrants? Quadrant 4 in reverse. So I look for the reciprocal of that, which happens to be 2 or root 2, square root of 3 over 2 for the sine. Who gives me the square root of 3 over 2 for sine in those two quadrants? Negative pi over 3. How was that? How was that? Where was there hiccups? No hiccups? Everyone's got this?
I have no idea what makes something defined. I know you pointed to this thing and you were like, oh, that's true, but I have no idea what you're talking about.
So when we're talking about where the inverse is defined, we have to restrict the domains of all of our trig functions or they're not 1-to-1. So that goes back to our very first day of inverses. We have to restrict the domain, and you all help me with the restrictions of the domain. For the sine, if we look at our sine wave, this is what the sine wave looks like. That's what the sine wave looks like. We talked about on the very first day that we're going to cut it at negative pi over 2 to pi over 2 to ensure that this is 1-to-1. To ensure that my inverse is only defined in those two quadrants. So when we're talking about where it is defined, it's asking me which quadrants do I get to have for the inverses of these. The quadrants for sine inverse to be defined is only in quadrants 1 and 4 in reverse.
And the inverse is just where the x and the y change.
Yes. And so what I'm chasing is the angles that produce those answers in the restricted domain of the original function. Yes? So the way in which that we have definitions for inverses is sine x, the cosecant x, the tangent x. Their domains are either from negative pi halves to pi halves, or for tangent, it is non-inclusive. So for this one is quadrant 1 and quadrant 4 in reverse. And I say reverse because we do the negative angles. For all the other ones, so for cosine, secant, and cotangent, your domains are either from 0 to pi, but for cotangent we don't get inclusive, because at cotangent those are where it's undefined. So that's in quadrants 1 and 4, or quadrants 1 and 2. How are we doing? Does that answer your question? Okay. So when we are doing the compositions of inverses, do you remember the time in which I really care and one time that I don't care? What is the time in which I really care and the time I don't care?
When the inverse is outside.
Yes. So when I'm doing this, I really pay attention for when the inverse is on the outer function. So if you want to just evaluate the inner function first, get an answer, and then evaluate the outer function with that answer, that's one way to always ensure that you're not going to have to worry about paying attention. If the inner function is the inverse, then you can just say, oh, here's the answer. But if the outer function is the inverse, then you really have to pay attention to where you're standing. Because we have this rule that says f inverse of f of x is equal to x, and f of f inverse is equal to x, provided, of course, it's defined in those places. The one you have to pay attention to is this one, because that isn't necessarily going to equal just x, because you have to go back to the quadrants in which it is defined. So as an example here, if I'm asked to find the sine of the tangent inverse is defined in quadrants 1 and 4 in reverse. When I see this, this is the answer, because it is the inverse. So when I have inverses, I have the answer, and I am chasing the angle that is equal to. So when I see the tangent inverse of -1, I am chasing an angle that produced that. So I find the tangent inverse of -1 first. Tangent's only defined in quadrants 1 and 4 in reverse. So the only place in which you get a -1 when you take the tangent inverse is at -pi/4, because that's in which it is defined. So I know that the tangent inverse of -1 equals pi/4. So like I said before, when I see the tangent inverse of the answer, it equals the angle. In this case, the angle happens to be -pi/4. So the sine of -pi/4 is my final answer, which is this. So pay attention who is on the outside and who is on the inside. You are always chasing the angle that produced that answer when you're doing the tangent, cotangent, secant, cosecant, sine and cosine of the inverse. You are chasing angles that produced those answers. So without using a calculator, determine what these answers are. So, just because there seems to be a lot of confusion, when I see this, the arc cosine of 1/2, I am chasing an angle. When I see arc tangent, arc cotangent, arc sine, arc cosine, arc secant, arc cosecant, I am chasing an angle that produced that answer. So this is equal to some angle. We're just going to call it theta. So what I know is the arc cosine of 1/2. I can write this as the cosine inverse of 1/2. These mean the same thing. And what I'm doing is I am finding the angle that produced that answer. Now cosine is defined only in quadrants 1 and 2 for its inverse. So only in quadrants 1 and 2, which angle has an answer in the x part of 1/2. So that means this inner function is equal to pi over 3. That means my theta is equal to pi over 3. That means what I'm really trying to find is the tangent of pi over 3. So then I just look on my unit circle. Tangent is sine over cosine. So I put my sine value over my cosine value, and my final answer is just the square root of 3. Do you all need me to do another one, or you got this now? Okay, so let's do B. If we take a look at B, I'm going to erase this for now, and it'll be on the video, don't worry, but I'm erasing it for now. As I take a look at B, this is the case in which I have to pay attention. The answer is not 3 pi over 2. The answer is pi over 2. Because this is the case in which I have to pay attention. My outer function is the inverse, and it is on a restricted domain for the cosine. So my range for the cosine inverse is between 0 and pi. Is 3 pi over 2 in that value? No. So I know that this is not going to equal 3 pi over 2. So the first thing I'm going to do is evaluate the cosine of 3 pi over 2. What is the cosine of 3 pi over 2? So it is 0. So what I really have then is the cosine inverse of 0. Cosine is only defined between 0 and pi so that its inverse will be an inverse. So it's 1 to 1. So where on the unit circle in quadrants 1 and 2 is the x value equal to 0? So your answer is pi over 2. So take a few moments to do the rest of these. Let's take a look at the last three. I have the tangent of the tangent inverse. When it's in this form and the inner function is the inverse, the answer is cool. It is just whatever that was. No work needs to be done on that. So then I'm going to be doing the arc sine of negative 1 over the square root of 2. If you rationalize it, it is negative square root of 2 over 2. In this case, it's not rationalized. Where is the arc sine defined? Which quadrants? 1 and 4 in reverse. So in quadrant 1 and 4, where do I get a negative square root of 2 over 2? So this is equal to the secant of negative pi over 4, which is equal to the negative square root of 2. How is that? The last one, the cotangent of the cotangent inverse. Is this just going to be 5 pi over 4? No, because I have to chase where I am defined for the inverse. So first I'm going to find the cotangent of 5 pi over 4. What is the cotangent of 5 pi over 4? Cotangent inverse of 1, what is that equal to? How was that? Yes.
You said you got the negative 5/4 from e negative 1 over square root of 2.
So this is one of those ones where when you see negative 1 over the square root of 2, that this is equivalent to negative square root of 2 over 2, if you rationalize the denominator. I don't ever require you to, but you'll see on the unit circle it is rationalized.
So you rationalize it and then flip the equation.
So once I rationalize it, I look to see where is the arc sine, or sine inverse, equal to the answer of negative square root of 2 over 2.
Okay, I understand now.
Okay, cool.
Okay, 'cause I just realized that you had to get the square root off the bottom, which means that you're going to be multiplying by it.
We're cool? All right, this next part, I do not have an angle that's on the unit circle. It is sweet. It's like the most delicious thing until you see U's and V's, then it gets even better. So what I know is that when I see the arc, I can replace it with theta. Whenever I see the arc of any of the trig functions, I can replace it with theta. So what I know is the arc cosine of 5 over 13 is equal to theta. Because I am chasing the angle that produces that. If I take the cosine of both sides, then I know the cosine of the arc cosine is just going to give me 5 over 13 because the arc part is already taken care of. So this is equal to the cosine of theta. The reason I'm doing all of that is because when I come over here, what I'm really chasing is the sine of theta. That's what I'm really chasing. How do we define the sine of any angle? So this is equal to y over r. What do I have exactly, though? I actually have x over r, where x is equal to 5, r is equal to 13. How do I find my y? So y is equal to plus and minus r squared minus x squared. Which one do I choose? Well, where's the arc cosine defined? Quadrants 1 and 2. Where is the answer positive for cosine in quadrants 1 and 2? Quadrant 1. So what I know then is that this is going to be the positive of it. There's a lot going on this particular question. So y equals 12. I heard the sigh and I feel the way. I feel the same way. I feel it. I feel it. So what this is finally equal to then is, let me just get rid of this. Do you? Was it cool? So this is simply equal to the sine of theta, which is equal to the y over r, which we found it to be 12 over 13, and that is my final answer. Notice I did not need to find the angle. Unlike the previous examples, I found the angle simply because I knew what it was on the unit circle. In this case, I don't need to find the angle, so try B. I'll give you a moment to try B. So the question is, what do you do with the 2? So this is the cosine of 2 theta. All right, so if I'm asked to find 2 times the tangent inverse, it's just 2 times my angle. Whenever I see the tangent inverse or any trig inverse or arc of any of the trig functions, that represents theta. It is representing the angle. So the tangent inverse of 5/7 is simply equal to the angle that I'm chasing. But I'm not actually trying to find the angle, and I'm not going to find the angle. So I'm not going to put that in my calculator and say, here's the angle. So what I do know, though, is if I take the tangent of both sides, I'm going to get 5/7 is equal to the tangent of theta. Now I'm going to go back up, and I'm going to pause for a minute. I'm going to go back up and do the cosine of 2 theta. I have 3 choices. Doesn't matter which one you choose. I'm going to choose 2 the cosine squared theta minus 1. There are 3 choices for the double angle. I'm going to choose that one. So then I'm going to come back down to the red and say, okay, what do I have? If I have tangent, what values do I have? I have the y value. I have the x value. What do I need for cosine? I need the r value. So r is equal to the square root plus and minus 5 squared plus 7 squared. Tangent inverse of 5/7 is positive. So which quadrant am I in? I'm in quadrant 1. So that means I take the plus part of it. And what is 49 plus 25? 64? 74? So I have the square root of 74. So that means that this is equal to 2 times the cosine, which is 7, over the square root of 74, the quantity squared minus 1. So that means that this is equal to 2 times 49 over 74 minus 1. The 2 and the 74 reduce to, what is that, 37? Is that right? 37? So then I have 49 over 37 minus 1. So in other words, I have 49 over 37 minus 37 over 37. What is my final answer? What's 49 minus 37? So there's my final answer, 12 over 37. So on C, this is equivalent to the tangent of theta divided by 2. And I would work it that way. So let's talk about this one. It is the last one. These are always on the test, or they should be when you write it. Is the cosine of the sine inverse of u. Now the only difference from what I just did and what I have now is I don't know what u is. U could be 5/7. We don't know what it is, but we're still going to do the exact same thing as we did before. When I see the cosine of sine inverse of u, I know that this is always going to happen. This is equal to theta. So I did it numerically. Now I'm going to do it non-numerically. So whenever I see arc sine, arc inverse, or arc inverse sine, or any of those, I know that it is the angle. So when I see that, I replace it with the angle. So going through this example, the first thing I did is like I did before, is I let that arc sine or sine inverse equal to theta. Take the sine of both sides. So I get sine theta is equal to u. Sine theta is y over r. Y is u, r is 1. That means x must be my radius squared minus my y squared. So 1 minus u squared. So my final answer is just going to be 1 minus u squared, the square root of it. Let's go through another example, though. Which one of these lovelies would you like me to do? Okay, we'll do number C. So the first thing I'm going to do is say let theta equal the arc sine of u. if I take the sine of both sides,
What does that mean?
do you square both sides? Do you take square roots of both sides? Those are functions. So what we're trying to do is we're trying to use that rule that says if I have the sine of the inverse sine, it equals my x value. So I'm using the relationships that we know from pre-calc 1 that says if I have the f inverse, or excuse me, the f of f inverse of x, this equals x. So coming back to this, I get the sine of theta is equal to u. How do we define the sine of theta? Y over r. So if this is what we have, what is y? I can always put anything over 1 as my placeholder. That tells me that y is u and r is 1. I am chasing the secant of my angle. How do we define the secant? It is the r value over the x value. So what do I need to find to answer this question? I need to find x. So I come back over here, and x is equal to plus or minus r squared minus y squared. But what is r squared? 1. What is y squared? U squared. So my final answer is going to be 1 over the square root of 1 minus u squared, and there's my final answer. How was that? We have finished this section. Have a great day. Think about which questions out of this you'd put on your test. Let's do another example. Let's do A. So with A, I know that when I see the arc or the inverse, in this case the arc cosine of V, this is equal to the angle theta, or whatever angle you want to call it. So then if you take the cosine of both sides, then what you'll end up with is V is equal to the cosine of theta. Now remember, we defined the cosine of theta as being my x value over my r value. Because it is V over 1, that would give me r is 1 and x is V. Because I want the sine of my angle, the sine of theta, the sine of my theta is y over r. So what I have to do is I have to figure out what y is using this information here. So I know that x squared plus y squared is equal to r squared. That means y is equal to plus and minus the square root of 1 minus v squared. Because x is positive and r is positive and cosine is in, the arc cosine is defined in quadrants 1 and 2, we know that it is the positive. So it is the positive square root. So y is equal to the square root of 1 minus v squared. That means the sine of theta is equal to the square root of 1 minus v squared over 1, or in other words, my final answer is 1 minus v squared.